Today's section is 6.4, Compound Inequalities. This is a challenging section, so you may have to stop and rewind more than once if you don't understand something. Let's talk about this scenario. Mrs. Maz only eats chocolate that is milk chocolate and has peanut butter in it. While Mrs. Matoliak will eat any chocolate that is milk chocolate or has Krispies in it. Who has more options? Now, you might be thinking, well, how many candy bars have peanut butter in them? How many have Rice Krispies in them? Okay? Really, you want to be focusing on this and this or here. Okay? And we can even simplify this by saying, let's just cross out Rice Krispies and write peanut butter. Okay? So let's say I'll only eat chocolate that is milk chocolate and has peanut butter in it. And she'll either eat milk chocolate or candy that has peanut butter in it. Okay? So let's consider this. We've got all of the milk chocolate candy bars in the world, represented by this circle. Then we have all of the peanut butter candy bars in the world considered here. I'm trying to think. Now, Mrs. Maz, will only eat chocolate as milk chocolate and has peanut butter. This is called a Venn diagram. So this is only what I will eat. I will only eat these candies that have milk chocolate and peanut butter in them. Okay? So that's my spot there. Now, Mrs. Matoliak, she's less picky. She will eat anything in the milk chocolate zone and anything in the peanut butter zone. So, Mrs. Matoliak will actually have more options because she is not as picky as Mrs. Maz is. So, we want to consider that as, and we will get back to the idea of if it's an and, like for me, an and means they have to both be true. So we're finding the place where the two groups overlap, okay, where they overlap. So if I'm saying an and, I'll only eat the candies that fit into both groups, which means where they overlap. If it's an or, that means you include both circles. And that gives you a much broader possibilities. Okay? So that's the first thing we have to think about and consider. The second thing we want to talk about is what is a compound sentence? So you've learned this in English. Do you remember? A compound sentence, a sentence that has a conjunction in it. That's probably the simplest way to say that. Or two sentences combined with a conjunction. So the dog is red and furry. Okay, that's really technically two sentences. The dog is red and the dog is furry. But we can add that conjunction in there and say the dog is red and furry. So a compound sentence is very similar to a compound inequality. Compound inequality is two inequalities combined by, and it's a conjunction, but we're specifically talking about an and or an or. Okay, two inequalities combined by an and or an or. So that brings us to the two types of compound inequalities. The two types are, of course, the and the or, the picky and the non-picky. Okay? And the thing you want to understand when we're talking about the two types of compound inequalities is what we were talking about up here. When you do a compound inequality that's an and, you need to find where the two inequalities overlap. So when you think of the conjunction and, you think of the keyword overlap. If you have the conjunction or in the inequality, then you will bring both inequalities down. And that might seem confusing right now, but we'll get back to that and and you'll understand what I mean here. Okay, so first we're going to talk about the and examples. Okay, it says graph all the real numbers greater than or equal to 0 and less than 4. Now the first thing we need to do is take this compound inequality and translate it into a compound inequality with symbols. Okay, so we know that we want all the real numbers that are equal to 0 and less than 4. Now before we do that, let's actually just think about this. Here's 0, here's 4. So greater than or equal to 0 and less than 4. Where would those numbers be? Greater than or equal to 0 and less than 4. Okay? Greater than or equal to 0 would be like this. But it has to be less than 4. It can't be 4, so we use an open circle. So this is what we're talking about. Greater than or equal to 0 and less than 4. It has to fit to both of those. So let's go the long way here and translate this. All the real numbers, now for algebra purposes, we only talk about real numbers. So for now, you can kind of just consider all the numbers greater than or equal to 0. Let's write that first. All the numbers x greater than or equal to 0. And, write that word down, and less than 4. Now here's the problem. This second half of this compound inequality doesn't have a subject, but the subject is still x, so we have to include the subject in the second half, less than 4. So if it said the dog is red and furry, and you had to write it into two separate sentences, you'd have to say the dog is red and the dog is furry. So the subject has to be in both inequalities, the x. You can't just do this. X is greater than or equal to 0 and less than 4. You have to have a complete inequality here and a complete inequality here. Now, if we were to graph these, this is what would happen. X is greater than or equal to 0. What we'll do for a compound inequality is we're going to graph the original inequalities above the number line, and then the final makes it down to the graph. So if x is greater than or equal to 0, that'd be a closed circle, and everything to the right. Greater than or equal to 0. Now this one, x is less than 4. That would be an open circle, and everything to the left. Now it is best that your arrows go all the way to the end of the number line, so you don't cause any confusion later on. So don't give me just a squatty arrow like this, okay, that stops here. It needs to go all the way to the end of the number line so you can really see what's going on. And if we go back to the and idea, we're finding where they overlap. They overlap right here. So the final graph is only the place where they overlap because it's an and. So what I want you to do actually, if the conjunction is and, I want you to also include somewhere in the problem that the key word is overlap to remind yourself you're finding the place where they overlap. So you can shade it in here, but the most important thing is that you put your final graph on the line. Okay. So here are your steps, if you can read them. Solve both inequalities. Graph both inequalities above the number line. Use the conjunction to decide what to bring down to the line for your final answer. Okay? And that includes writing the conjunction's keyword. So you always need to include a conjunction and or, and the keyword, overlap or both. So let's continue through these. This one's already solved for us. We're just practicing our graphing. Now on your number line, you need 0, you need -1, and you need +6. And now spacing, I don't care. As long as your negative numbers are to the left of 0 and your positives are to the right of 0. So if x is less than -1, here's -1. We're going to graph less than -1 above the number line. X is less than or equal to 6. So it can equal 6 and be anything less than 6. So it doesn't matter which one of these is on top. It makes no difference at all. As long as you have both of them above the number line, then you're fine. Now this says and, which means I need to find where these two overlap. And where do they overlap? They overlap right here. So we're going to bring this end point down, open circle, and shade everything to the left because that is where they overlap. So for any and problem, you're only bringing down the place where they overlap. That's it, nothing else. Let's try another one. Number 3. Now, these are squish problems, I call them. A squish. In a squish problem, you can see there is no and or. So you have to know that in a squish problem, this is always going to be an and. A squish problem is always an and. So the and problems either say and or they're squished together. Okay? Now, in a squish problem, the ultimate goal is to get the variable alone in the middle. Get the variable alone in the middle. So we have to understand that we've got to get this x alone in the middle, and we also have to understand that there's actually 3 parts to this inequality instead of 2 like there normally are, a left side and a right side. There's a left, a middle, and a right. So if I want to get x alone, of course I need to subtract 2. But you have to remember, you have to subtract 2 from the right, subtract 2 from the middle, and subtract 2 from the left because there are 3 sides here. Okay, so 7 minus 2 is 5 is less than x, which is less than 9. Now these are still inequalities, so if you multiply or divide by a negative, you still have to flip the inequality symbol. But we just subtracted 2, so there's no flipping. Now this inequality, we need to split into 2 inequalities. There's one here on the left side, and there's one here on the right side. Now the one on the right says exactly what it is. X is less than 9. But the one on the left has the x on the right side. So we need to rewrite it so the x is on the left side. X is greater than 5. Okay? So it was a less than symbol. We have to flip it over to greater than. So now we have x is greater than 5, and that should be written in there. X is less than 9. Okay, so if it's an and, that means we're looking for where they overlap. Write that down. That's important. That's your key word. And let's go ahead and graph this. Why don't you give it a shot? Try to graph it on your own. Pause here for a second. All right, so we've got 0, 5, and 9. X is greater than 5, so that's an open circle at 5 and everything to the right. X is less than 9, so that's an open circle at 9 and everything to the left. Draw those arrows till the end of the number line. We want to find where they overlap, which is right here. So bring this end point down, bring this end point down, and just graph the place where they overlap. Okay. Number 4 is very much like number 3. Why don't you give number 4 a try all by yourself. Push pause here, do all of number 4, and then come back and see how you did. All right, in number 4, we need to get W alone, so we subtract 3 from both, or I should say all 3 pieces. 6 minus 3 is 3, is less than W, which is less than 8 minus 3, which is 5. So our key numbers are 0, 3, and 5. We need to rewrite this one, flip it around. W is greater than 3. Rewrite this one. W is less than 5. You're actually not rewriting it, just write it again. So now let's graph. W is greater than 3. Open circle at 3 and everything bigger than 3. W is less than 5. Open circle at 5 and everything less than 5. And we should have the word and written in here, which means we're looking for where they overlap. And that would be right here. So that would be our answer. Okay. Now tomorrow we are going to add we have to give some other answers here, set notation and interval notation, and we'll talk about that tomorrow. Okay? Those are your and compound inequalities. What happens if it's an or? Here are your or examples. All the real numbers less than -1 or greater than 2. So if we're looking for any number less than -1, we're looking for these numbers. Or they can be numbers that are greater than 2. Like this. Okay? So let's graph these, or let's go the long way here and see what we did here. So we know all the real numbers, again, x, which is less than -1 or greater than 2. And remember, you have to have a subject in this inequality, and you have to have a subject in this inequality. So the subject is the same, which is x. We graph x is less than -1 above the line, and x is greater than 2 above the line. And the key word for an or is that you bring them both down to the final graph. Down and down. Okay? And there's your final answer. So for number 6, this is in set notation, but it's going to be the same thing. X is greater than 3, or x is less than or equal to -1. So here's -1, here's 0, here's 3. X is greater than 3 would be an open circle at 3 and everything greater than 3. X is greater than or equal to -1. Greater than or equal to -1. Okay, now it's an or, so the key word is both. When we bring them both down to the number line, what will happen? Okay, so let's say I bring this one down first. Open circle, shade it to the right. Then I bring this one down. Close circle, shade it to the right. Now when this shading comes through this open circle, it's actually going to close in that circle and it just becomes part of the number line. So there's actually no circle there anymore. It's like it fills up that circle and wipes it away. Okay? So this would be our final answer when we bring both of them down. Let's look at 7. Now these are two inequalities. We have to graph or solve them both. So the one on the left is solved completely separate from the one on the right. So you can draw a wall there if you want. They're totally separate. Add 7 to both sides. 4x is less than 25 plus 7, which is 32. Divide both sides by 4, and we get x is less than 8. The right side, completely separate. We've got to move that 12 over, so we subtract 12 because it was a positive 12. And we get -9x is greater than or equal to 18. Divide by -9, and we get x is less than or equal to -2. Did you flip? Did you flip the symbol? Okay. You need to flip the symbol, and then 18 divided by -1 would make that -2. Alright, so we've got a -2, we have a 0, we have an 8. This is an or. Before you graph anything else, if it's an or, you should write both. And I would actually suggest before you even start solving that you figure out what the key word is first and then solve. So x is less than 8, that's going to be an open circle at 8 and everything to the left. X is less than or equal to -2. That would be a closed circle and everything to the left. Now we want to bring them both down. So the bigger one is basically the one you're going to bring down. Open circle, because it will overlap on that one anyway. So if I bring the big one down, then when I bring the little one down, it's going to be covered anyways. And that closed circle is just represented by this shaded in region anyways. So it's everything less than -8 for your final answer. We do have some special cases. Let's talk about what happens in these special cases. In number 8, it's an or. So before you do anything else, what's the key word that goes with or? That would be both. Okay? and solve each of them and graph each of them. So what I'd like you to do actually is to do number 8 and number 9 on your own. See if you can figure out why they're considered special cases. And when they get weird or you get confused, just stop. But they do start out normal. So go ahead and do 8 and 9 on your own and then come back and we'll see how you did. So number 8, we need to move the 4 over, so we subtract 4. X is less than or equal to 8. And then here, we need to move the 2 over, so we add 2. X is greater than or equal to 8. So we've got two key numbers, 0, which is always included, and we have 8. So when we graph this one, x is less than or equal to 8. That's a closed circle and everything to the left. X is greater than or equal to 8. That's a closed circle and everything to the right. Now if it says I'm supposed to bring them both down because it's an OR, what happens when I bring them both down? We have this shaded region and a closed circle, and then this shaded region. So what we end up getting is the whole number line is shaded in. There are all possibilities. And if we have the whole number line shaded in, you either need to say all the real numbers, or you can use the real number symbol. So the first special case is when the whole line gets shaded in, then that means all the real numbers will make this true. The second special case, if you haven't tried it, try it first. We're going to graph 0 and 3 and 6. What is the conjunction, or it is and the key word that goes with and is the place where they overlap. It says x is less than 3. X is greater than or equal to 6. Okay? So I'm looking for a number that's less than 3 and greater than or equal to 6. Think about that. I'm looking for a number less than 3 and greater than or equal to 6. So I'm trying to find where these two overlap. Do they overlap? They do not overlap. So that means, look, there should be nothing on the number line. The number line represents where this happens. And this doesn't happen at all. These two shaded regions never overlap. So do not put anything on the number line. And the answer you either write is no solution, or you write the empty set. Okay, no solution, or you write the empty set. Okay. Make sure you don't put something on the number line and then say no solution. Okay. Finally, quick graph practice. Put the final solution on each number line, given the graphs and conjunction for each problem. So I've already graphed them for you. It says OR. I want you to do A and B first. And we will actually check those in class tomorrow. So go ahead and do A and B, bring those to class tomorrow.